In this video, I will be talking about capacitive proximity sensors. I will explain what a capacitive proximity sensor is and how they work. I will also talk about some of the different types of materials these sensors can detect, explain the main parts of these sensors, talk about some of the different types of capacitive proximity sensors, and I will give some examples of how these sensors are used with automation. If this is your first time here and you want to learn more industrial automation topics and keep your knowledge up to date, make sure to hit the subscribe button and the bell notification icon so you don't miss anything. A capacitive sensor is an electronic device that can detect solid or liquid targets without physical contact. To detect these targets, capacitive sensors emit an electrical field from the sensing end of the sensor. Any target that can disrupt this electrical field can be detected by a capacitive sensor. Some examples of the solid materials a capacitive sensor can detect are all types of metal, all types of plastic, wood, paper, glass, and cloth. Capacitive sensors can also detect liquids like water, oil, and paint. Some capacitive sensors can be used to detect material inside a non-metallic container. The capacitive sensors used to do this have an adjustable sensing range. I will explain how to adjust these types of capacitive sensors with an example in just a bit. Capacitive sensors have four main parts: the sensor's body, the sensing face, the indicator light, and the cable or cable connection end. If the sensor has an adjustable sensing range, it will also have an adjustment screw to adjust the sensing range. Inside the sensor's body is where the circuitry is that makes the sensor work. The sensing face is the part of the sensor that is used to detect the targets. The indicator light is on the other end of the sensor from the sensing face. This light turns on when a target is within the sensor's sensing range and turns off when the target is out of sensing range. The sensing range of a capacitive sensor is the maximum distance a target can be detected from the sensor's sensing face. An example of being within the sensor's sensing range would be if the target is 6 millimeters away from the sensing face and the sensor's sensing range is 12 millimeters. The sensor's sensing range can be found on the datasheet of the sensor, or you can look it up on the manufacturer's website. These sensors can be purchased with a cable already attached to them, or they can have a connector that the cable screws into. In this cable, you will find 4 wires. The colors of these wires are brown, blue, black, and white. The brown wire gets connected to 24 volts DC positive. The blue wire gets connected to 24 volts DC negative. The black and white wires are the sensor output wires. The black wire is the sensor's normally open output wire. The sensor will send out a signal on the black wire when it detects the target. The sensor stops sending this signal when it does not detect a target. The white wire is the sensor's normally closed output wire. The sensor will send out a signal on the white wire when it does not detect a target. The sensor stops sending this signal when the target is detected. A capacitive sensor's outputs can be a positive signal, or PNP, or a negative signal, or NPN. Depending on how the sensor outputs will be connected, will determine what style of sensor outputs are needed. If the capacitive sensor has an adjustable sensing range, it will have an adjustable screw. Turning the screw clockwise increases the sensitivity of the sensor, and turning the screw counterclockwise decreases the sensitivity of the sensor. Mounting a capacitive sensor can be easy. It mostly depends on how the sensor is going to be used and where it's going to be located. Some styles of capacitive sensors can be mounted by just bolting them into place. Other styles of capacitive sensors can be mounted by drilling and tapping a hole the same size as the sensor, and sometimes using a bracket to mount the sensor is the best solution. Now, I will explain how to set up a capacitive sensor to detect water in a non-metallic container. In this example, I will use a drinking glass made out of plastic for the container and a capacitive sensor with an adjustable sensing range that is mounted on a post to detect the water. Notice when I put the empty drinking glass next to the sensor's indicator light turns on. This means the sensitivity of the sensor is set to high and will need to be adjusted. To adjust the sensitivity of the sensor, turn the sensitivity adjustment screw counterclockwise until the indicator light turns off. Now, I will fill the drinking glass with water up to the sensor. Notice the indicator light turns on. If I remove some of the water to where the level is below the sensor, the indicator light will turn off. This means that the capacitive sensor is adjusted correctly. Capacitive sensors can be used in many ways. They can be used for part detection on workstations, conveyors, and robots. They can also be used for counting and checking liquid levels. When these sensors are used for part detection, the sensor just sends a signal to the workstation, conveyor, or robot so they know when the part is there. A capacitive sensor can be set up on a conveyor to trigger a counter so that it can count how many parts have been built. Capacitive sensors can also be used to check for high or low tank fluid levels and to trigger alarms for each. In review, by watching this video, you have learned about capacitive sensors, that they detect most solid or liquid targets without physical contact by creating an electrical field. You learned the four main parts of a capacitive sensor and that they have many different options to fit the needs of most applications. That should do it for this video. Please let us know if you have any questions about capacitive sensors in the comments below. Also, make sure to like this video if you found it helpful. This will help other automation engineers like you find this video. Thanks for watching. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.